Yes, so using LLVM's libc. So let's start off with the agenda. So first we're going to start off with a brief introduction to LLVM's libc and its current status. Then we've got building and installing the libc. We're going to do a brief demo. Using the libc to link real applications, another demo. A quick guide to bringing up LLVM's libc for a new platform or architecture, and also future plans and guide to participating in this future development. Yeah, so let's start off with the introduction. So what is LLVM's libc? Well, it is a libc that is greenfield, so developed completely from scratch. It's sanitizer friendly, implemented in C++ source code with assembly only where absolutely necessary. It's tested. We have unit tests, integration tests, exhaustive tests, and they're all running on CI. So we know that it is stable at head, and it's modular and configurable. So you can use only the parts you want, and you can configure them to behave in the ways you want. And so these are also some of the reasons that we started working on this, because there's no other libc that provides this combination of attributes. Two, you can tell us about the implementation status.
Okay. Yes. So as of current, we have more than 400 functions implemented, and following the C and POSIX standards. But some of them are not completely fulfill all the edge cases of the standards. But that is the work on progress to finishing that. And among them, we have a large part from functional SDIO and the thread libraries. And most of the string functions are implemented, except we don't support the locale yet. And for the math functions, we almost finished the single precisions, and we started to work on double precisions and long double. Right. And so for the allocators, we have integrations with the Scudo standalone allocator to be used with the libc, and there is a detailed instruction of how we can do that for the Scudo. And for the executables, currently we only fully support the fully static linking, and we don't have the dynamic loaders and other static PIE mode yet, but that's going to be our near target. So for the platform and the architecture coverage, currently we have supported and tested on the Linux, Windows, and macOS with a mixture of x86 and the ARM64. We started to work on the support for ARM32 for embedded system, but that work still needs a lot more coverage. And among those, we set up the continuous integration pipeline for both the Linux and Windows, and we plan to bring up for macOS soon. And currently, the compiler support on all of those CIs are Clang, mostly the system Clang and the head, but we do want to support the GCC at some point. All right.
All right, let's move on to talking about how to build a libc. As Luke and Michael have said earlier, we're going to run this in an interactive fashion, so we're going to present a lot of commands. You can try. If you can actually, if those commands will run quickly, we'll let you know. If they're not going to finish now, then we'll let you know also, don't try them. But yeah, so stop us at any time and ask us questions. We're happy to answer. If you're not able to answer, we will find the right people to answer the questions. All right, so we'll start with building the libc. We can build the libc and use it in two different modes. So first mode, we call it the overlay mode. In this mode, we used LLVM's libc along with the system libc. We also use the headers from the system libc. We use even the startup objects like CRT1.0 or CRT1.0 also from the system libc. I'll come to why overlay mode is useful, but let me first talk about the other mode, the full build mode, in which we use LLVM's libc as the only libc for your application, like it is the drop-in replacement for your system's libc. We use headers from LLVM's libc and also the startup objects like CRT1.0. Let's look into the overlay mode in detail. All right, the overlay mode. So, as I said, to use. Sorry. Yeah, as I said, in the overlay mode, we want to use LLVM's libc along with the system libc. The idea is that we exploit the link order semantics, like we put LLVM's libc static archive before anything else. So functions from LLVM's libc are picked up over system's libc. We need to use headers from the system's libc and also the static objects. Because of this, there are certain limitations. Like we can't use file operation functions or thread functions from LLVM's libc in this mode. We can only use functions which are not sensitive to ABI or type definitions like strl and round, most mat functions and string functions. Why would this be useful? There can be a couple of reasons at least. One of them is that maybe you plan to switch over to LLVM's libc eventually. And so this gives you a transition path. You start using those simpler functions, put in all the plumbing in place. And then when it's full enough, you can actually remove your system's libc, and this will just work as your the only libc for your applications. The other reason could be that we have actually implemented some of the functions ground up using modern principles and latest and greatest. Can I use great? Okay, latest practices and state of art. For example, Michael talked earlier in the day about string to float conversion, and Tu is going to talk tomorrow about math functions. So some of our implementations are much faster and more accurate. The math functions and the string to float are faster than glibc. So that could be one of the reasons why you want to start using LLVM's libc in the overlay mode. All right, so let's actually get to building the libc in the overlay mode. We are part of the LLVM project, so we use the standard LLVM conventions. We need to include the libc in the list of enabled projects, and the rest are normal CMake options that one would use to build any LLVM project, for example, Clang. And once you're done with the CMake configure step, you go run your generator. Like in this example, we have Ninja, so you run Ninja LLVM libc. Optionally, like as I have shown in this command here, there's a CMake install prefix specified. If you do specify that, then you can go and install LLVM's libc in the directory listed or specified for the CMake install prefix. Now, the build product of the Ninja step is a static archive named lib_llvm_libc.a. Oh, by the way, most of this tutorial is for specifics on Linux, on ELF-like systems. We have not yet brought it up on other systems. We do have a little bit of Windows support, but we have not done, the coverage is not as wide as we have for Linux. All right. Yeah, this is one way to build a libc. There are a couple of other ways. We have listed another way to build a libc. This is called the bootstrap build. This used to be called as the runtimes build. This was actually prompted by the libc++ project because libc++ is very sensitive to the version of compiler that is being used to build it. So they have invented this type of build called build called the bootstrap build, in which you specify Clang as the enabled projects and list runtimes like libc, libc++, libc_xxabi as the enabled runtimes. And what this does is, when you do the Ninja step, what this does is actually builds Clang from head and uses that Clang to build the runtime libraries listed here. So this is another way to build the same static archive that we would get from the normal enabled projects approach. All right, so how would you use this? As I said, we just use the link, exploit the link order semantics. So you specify the path to the static archive and the minus lowercase l option for LLVM libc, and then the compiler driver will magically link or pick, the compiler driver will get the linker to pick whatever's available in lib_llvm libc.a and the rest from the system's libc. You can try it if you want to. And we actually did try linking this to an existing LLVM binary. Like in this example, in this slide, we say that we tried to link to LLVM opt copy, and then you can actually see that the number of symbols it pulls from your system's libc, in our case, the system's libc was glibc, so it drops from 112 to 58. Michael will actually run these commands for you and show what happens.
Yeah. Okay, so here's the cmake command for just building LLVM's libc in overlay mode. So I'm just going to run that real quick. Should take about 15 seconds. It's skipping a bunch of entry points that are just, these are the ones that have ABI compatibility issues or need to be in full build mode because they involve using a libc's specific data structures. So file is different between different libcs. And now we're going to do ninja LLVM libc. And it will just build all these objects. And there you go. That's done. And now LLVM. Oh, actually, before I do this, let me just go up here. I'm going to just show you that I've already done the change to LLVM obj copy. So down here, you can see target link libraries, LLVM obj copy, LLVM libc. So it's going to link in LLVM libc before the system libc. So let's just build LLVM obj copy. All right. I built it before, so it's not taking very long. And now we're going, I could show you that one, but I'm going to show you the one I prepared earlier because that way I can be sure that it worked. Here we go. Okay, so we have LLVM obj copy dash glibc. So this is the one built with glibc, and if I just take off that last bit, you can see it's got a whole bunch of glibc symbols. Now, if I switch it to the one built with LLVM libc, you can see it's only got 58, and they are a different set, mostly ones that are that you would expect to require specific libc. So like the allocator, the kill, the p-threads, all of these require a tighter integration than we can achieve by just replacing some of the functions. So yeah, you can try this and then obj copy. So just to show that it works, you can see it works. All right. Now back to here.
All right. So that was with LLVM obj copy. But if you're bold enough, you can go and add LLVM libc to everything in the LLVM directory. Add LLVM libc as the target link library to everything in the LLVM directory. And it should mostly build. I actually done it. It builds, but the test suite shows few regressions. We have not gone and investigated why. But in the earlier case, with just LLVM obj copy, there are no regressions. But when I go and link to everything in the LLVM directory, there are some regressions, like 110 or so of 40,000 odd test cases. So it's not much. One day we'll get to it and fix and hopefully actually build everything in LLVM libc in LLVM with LLVM libc. All right, so this is about the overlay mode. We will move on to the full build mode. Yeah, as I said, full build mode is the mode in which you use LLVM's libc as the only libc for your application. So you use the headers, the static archive, and the startup objects. One limitation currently, though, is that we only support fully statically linked binaries, just because we haven't gotten to building a static pi startup object or a dynamic loader yet. But one day, eventually, static pi is like, it's going to happen in the near future. Dynamic loader might be a little bit later, a few years later, I don't know. All right. Building the full libc is straightforward. Again, we follow LLVM conventions, but the installation is a little bit tricky because we want to install in a way that it doesn't interfere with your system libc and mess up with your system. And there are a few other things that I'll talk about as we move on. For this tutorial, though, we will show how to set up a sysroot with only LLVM components like Clang, LD, compiler RT, and the libc. We cannot yet build real practical C++ applications. You can build C++ applications, but you cannot build those which use the C++ standard library, because C++ standard library headers include the libc headers and expect the libc headers to be complete. But we are not yet complete enough to satisfy the C++ standard library headers. So that is the limitation currently. But we will show later that we are actually good enough to build real applications. We will get to it in future slides. All right, building. It's very similar to what we did with the overlay mode. You just include libc as one of the enabled projects. This time we want to set up an LLVM only toolchain, so we have included LLD, compiler RT, and Clang. So we add this additional CMake option because we want the full libc. Previously we just wanted the overlay libc, so we didn't require this option. Next, we use scudo for the allocator in our libc. If you're not familiar with scudo, just Google search for scudo allocator, and then you'll see enough documentation about that. It's actually part of the compiler RT project today. It's implemented in a standalone fashion, as in it doesn't require any LLVM pieces. It just uses the libc, and so we use that as our allocator. So this option to CMake says that you need to include scudo. We want to build scudo against LLVM libc's headers. So this option tells CMake that you want to build scudo against LLVM libc's headers. Scudo includes another component called gwip asan. I don't want to go into the details of what exactly gwip asan is. You can, again, Google for it. For this demo, we don't want to include that, so we just set gwip asan off here. And then the last option is that, as I said earlier, that we don't support any dynamic loading or dynamic linking, so we don't want to build the scudo shared object, so we also set this off. And once you configure, you can go ahead and install the complete toolchain with this command. So you install Clang, the built-ins, compiler RT, the core resource headers, the libc, and LD. There's another piece that you will need to install once you are done with this installation, and that is the Linux headers if you're on Linux. Why do we need the Linux headers? The libc headers includes some of the Linux headers which are safe to include from user programs. Like these are the headers which don't pollute the user programs, like name pollution. So you need those headers. So we need to install Linux headers also in our sysroot. I will leave that as an exercise to people trying it out, because the exact way to install Linux headers differs from system to system. But the easiest hack, if you're actually trying it out now or want to try it out after this talk or whenever, is to just copy the headers from your sysroot, the system sysroot, and then put it in the different sysroot. All right, so we have actually done all this offline, and we are going to show you a few examples. But before that, I want to talk about the special compile and linker options that you would have to use if you want to link to this special libc that we have, this full libc that we have in a special sysroot. First is, for the compile step, you should add -- sysroot equal to the path to your sysroot. It's actually 2 dashes here, but the slides somehow has combined it into 1 dash. Same with the link option, -- sysroot equal to the path. This one is a single dash, --rtlib equal to compiler RT, and -- fuse LD equal to LD. We have few examples actually doing all of this with CMake, all the CMake machinery in place in the libc directory. You can go and look at them, try them out. But now Michael will actually do some demos.
Yeah, so we're going to start off with doing the example from the libc directory. So just so we're clear, this is the hello world program that we're using. And let me pull up the... so I'm going to build it first with the toolchain just on my own. So hello, it's in hello world. It's named hello world, very creative. And so if we just build, then it works. And as you'd expect, it says hello world, but we also have our CMake command, which, here we are, is just going to be right here. So this is just the CMake for the mini demo project that we have here. So this is going to set up that and hello world. And so this is also going to give us the same program just through the CMake machinery. And now we have some other things that we built beforehand with the full build mode. So we have a Lua interpreter, and we have tic-tac-toe, and we have SAM.
Yep, so these are examples of real-world applications that can be built with just LLVM libc.
Yeah, so this is printf tic-tac-toe. So this is a version of tic-tac-toe implemented entirely in printf. I didn't write this. This is written by the person whose name comes up when I show you the source later. But we can go through and just play tic-tac-toe about how you'd expect. So, you know, I don't know. Anyone want to pick a number? 8. Yeah. Well, I won. But yeah, here. So, if it will load. Here we are. So this is the source. It was written by Nicholas Carlini. And so here's the entire source. And then down at the end, it's just calling printf in a loop. So in case you were wondering, yes, printf is Turing complete. But we also have the Lua interpreter. So we can just use it live. So hello world. This works. But we've also got a little test program. So Lua. So you can see, calls functions, it does for loops, it does everything you'd expect it to do, because it is what you would expect. Yeah, and then I think the final one we have is SAM, which is a speech-to-text generator. And so I'm going to just run this real quick. So this is actually a remote workstation, so I could go to the trouble of copying the file all the way over, but I've already prepared it earlier. So let me grab that, and here's what it sounds like.
Hello, LLVM conference.
Perhaps not the greatest speech synthesizer, but it works. Yeah, so you can build most things that you would expect that don't use C++ and any of the like really obscure parts of libc. Like we don't have stir fry yet. Yeah, here we go.
Yeah, so of the examples, probably Lua was the most practical one, and it is written in pure C. You can actually tune its configuration so that it only uses pure ANSI C. So I built it in that mode, and that's what we could do. LLVM libc satisfies Lua's needs. Right, moving on. Any questions so far? I mean, you can ask questions about the libc in general also. Okay.
support the ARM semi-hosting library support system call interface?
I don't
think that's a no.
I don't think so.
No, we haven't attempted that before yet.
And another quick question. It sounded like you said minimal assembly. Do you at least allow to specialize mem copy, string length, string copy, mem move?
Yeah. So we have a lot of specialized mem copy, mem move, and mem set everything, but they're all written in pure C++. We don't use assembly at all. So I'll actually correct what Michael said. He said minimal assembly, but we use zero assembly. That minimal assembly that we use is all coming from inline assembly. So the compilers are actually reading our source code fully and not bypassing it. You were about to say something, and I probably interrupted you.
No, that's it.
Okay.
So bringing up LLVM's libc on a new platform and architecture. So it's the platform and architecture specifications are in the libc config directory. So if you want to find your platform, then it's going to be under target OS/target architecture. And then entrypoints.txt is the file that specifies which entry points or functions you'll find. So if you want to include like stir to F, stir to D, strlen, any random function, you have to list it in there. So the most complete one is going to be x86 Linux. And then you can probably just bring up a new architecture with some of these functions, like strlen and strcopy they're very simple and they're very platform independent. You can just use their existing code. Some of the other functions, so in source/support/OS-util, we have some OS-specific things. So that's where we store our syscall implementation, and that has to be system-specific, just because that's how syscalls work. So if you want to bring up those sorts of functions, you will need to add your own subdirectories there. They follow the same format as the config directories. And then if you want to do full build, you need a couple more things. You need an API.td that defines the types, and I think macros and a couple other things. And you need a headers.txt that tells it which of the headers to build. So when you are telling it to build libc, then it will generate only the entry points and only the headers you tell it to. So if you want a libc that only has like the odd numbered string functions, you could do that. It'd just be kind of weird. And then if you want more information, there's a porting document that you can read on the website. Yeah, two.
So for near future, near-term development, we would like to focus on completing the math libraries. So our single precisions is almost done. And so our next focus is going to be double precisions and long double. And if we have time, then we want to fulfill in the math function for C23 standard, which was finalized. And for stdio and pthread, we would like to complete them of the remaining functions. There are not too many of them. And we would like to improve our standard conformance, because there are a lot of edge cases that currently is not blocking on us, but it's going to take a lot of time to cover all of them. And also, we'd like to add more configurability for all of those functions and library, so that it can satisfy the need for other use cases, such as the embedded system, where they care much more about the memory footprint and the code size. And for starting up system or executables, currently we only support the fully static linking mode, and we would like to add the static PIE in the near future. As Siva mentioned earlier, the dynamic loaders might take some time because it's a little involved. And for the platform architecture coverage, we'd like to adding more of the CI pipeline, for example, like completing for the macOS for both Intel and ARM. And also improve the ARM32 coverage functionality. And we are currently working with the Fuchsia team to integrate the libc into Fuchsia. And maybe if someone have a nice RISC-V port, they can help us to bring up the RISC-V. Okay, and there are other small items such as we need to do the code style cleanup because currently it's kind of a little mismatch all over the place. And we want to move away from the table chain tools.
All right, before we move on, I would like to mention one thing. So we probably have a few things on the slide which are coming from, showing up without any previous discussion or explanation, but let me use the pointer. For example, we said continue integration into Fuchsia, but we never talked about Fuchsia. So our talk today is like a continuation of the talks from previous years. So we try to present fresh material and not repeat what we did last time. So we are actually actively working on integrating LLVM's libc into Fuchsia's libc. We have some of the Fuchsia team members here actually in the audience who are working on that. Likewise, we say move away from table gen. What is table gen and why do we have it here? So table gen is kind of DSL in LLVM world to automatically generate header files and a few other C++ stubs. So we use that to generate our header files. We found that table gen is not really scalable and not really easy to use, so we want to move away from that. That's one of our things to do in the near future. And what else is missing? Oh yeah, so code style cleanup. So the libc project went through a few different code styles. When we started the project, we started with the normal LLVM style. Then we moved on to the style currently used by the LLD project. Then we found that, okay, it's really not looking nice, and we moved to a different code style. When we've documented it, you can go to the libc's landing page and navigate to developer documents. Right at the top, you'll see the code style document. That's the code style we are using now, but we didn't clean up the entire source base to use the new code style. That's the reason why we have it over here. All right, so contributing. So if any of you or anyone is interested in contributing, we are happy to engage with you and take patches, but I would like to touch upon a few things. So maybe you want to contribute a new port to a new target or platform. Well, Michael actually went through all the details that you need to put in place before you can bring up a platform. Bring up a port on a target or a platform, but there we do have full documentation now on the libc website. You can navigate to this page and you'll find all the details. When you are actually coming with a new port to a target platform, we also would like to see a plan to stand up a CI builder and testing. What's the threshold for failures? For example, if I'm working on the libc and I break your platform, do we revert my code, my patch? If you are going to revert my patch, then you'll have to provide ways for me to reproduce and understand the reason for the failure. So we have to discuss all those. We have a few other items also with respect to contributing. It's just a continuation of what we talked about earlier as to what we want to do in the near future. One mechanical thing is cleaning up the code style. We showed you how to link the overlay libc with the existing LLVM binaries. We probably want to do that in general for everything in LLVM libc, just as a way to, as a proof of concept, and also as a preparation for future when the libc is complete enough. You just do it that way as the standard approach. We don't package any of the libc binaries with LLVM binary releases. So we should probably start putting plumbing in place to do that. Another medium complexity product would be implementing syscall wrappers. So most of POSIX on Linux can be implemented as simple syscall wrappers. We have a lot of syscall wrappers implemented, but we have a lot more to go, so you can help us plugging those gaps by implementing more syscall wrappers. We have a random number generator now, but its range is not wide enough, so we want a better random number generator with larger range, better performance. And as Stu has said, earlier, we are just beginning to work on double and higher precision math functions. So if you have any cool idea about them, feel free to engage, start a discussion, or send a patch. We're happy to engage, review patches. And the last thing is about communicating with the developers. We have a Discord channel and a discourse topic for the libc. And if you're actually using the libc or trying the libc and find bugs, feel free to file bugs. All these links, you can find them under external links on the libc landing page. I think that's about it. We will take questions, if any. Thank you.
Thank you. It was a great talk. I have a question. You mentioned earlier that the library is sanitizer friendly. Can you expand on that? What exactly that means, and which sanitizers are you talking about?
Yeah. Existing libcs. There are sanitizer experts in the audience, so I might, if I make any mistakes, please correct me. So the most popular libc, glibc, or let's say, I don't want to name it libc. So glibc, parts of glibc are implemented in assembly language, and so they can't be instrumented by sanitizers because I believe sanitizers work on the IR. Yeah. So if you write them in assembly, you can't instrument them with sanitizers. So that's one reason. There are a few other things, like for performance reasons. For example, glibc's strlen or strcopy, they depend on undefined behavior. And so sanitizers will just throw up on that, right? So we don't want to use things like that. So we want it to be sanitizer clean from the beginning. Does that answer your question enough?
So there were two sort of dependencies on pre-existing stuff that were mentioned. One was Linux headers, and other was like any other libc for libc support in general. And I was wondering if the plan included, getting away from Linux headers or being able to include libc on top of libc as sort of a test.
I get the part about Linux headers, but I don't quite get the part about libc XX. But let me answer the Linux question and then we move to libc XX. So ideally, we don't want to move away from using Linux headers because we just don't want to copy what's there in the Linux headers and put it in the libc headers. That way we are copying one thing. Other thing is if the Linux headers change in future, then we'll have to update our libc headers. And there could be many Linux versions with many different values in the headers. So I don't know if it's going to be maintainable in the long run. We do have a precedent, right? glibc does include few Linux headers, and we are following a similar approach. Muscle, for example, doesn't include any Linux headers. It copies everything from the Linux headers over into its own headers. Can you explain the libc XX question a little bit?
Yeah, just being able to use a full runtime stack from LLVM, not needing to use muscle or glibc for just libc XX in general, if there was a plan for that.
Yes, that's definitely in the plans. So I think the gap is not much. We need to close our math and string.h gap. Like these are the two headers that I know of that libc XX headers require. Once we are complete, then we should be able to build practical C++ applications also with purely LLVM only toolchain.
Thanks for the talk, gentlemen. I'm assuming that you've done the performance comparison against glibc. Obviously, we get some advantages because we can statically link things, but maybe it's not quite as finely tuned and optimized. How are we doing in comparison against glibc from a performance standpoint?
It very much depends on the function. Some of our functions, like stir to float, like I was talking about earlier, are notably faster. Some of the math functions that 2 has been working on are also notably faster. There are a lot of functions where performance doesn't really mean anything, like C-type is very much they're like one-line functions. The performance doesn't really, our performance is going to be the same because our code is going to be very similar because there's only one way to figure out if something is a number. But there are also going to be a lot of functions where, as you mentioned, we haven't had as much time to tune, and so there are going to be some functions that are slower. I can't think of any right now.
Yeah, so strlen is one example, right? We don't want to use UB, so we do we iterate over bytes. Other libcs iterate over words, so there's the obvious performance degradation. But it's strlen. I don't know if strlen, maybe there are applications where strlen actually is in the critical path or is hot, but I'm not aware of in the places that I'm interested in of strlen being hot.
Okay, have you tried measuring like a reasonable workload, like a Chrome renderer or like Chrome renderer testing or something like that, where you have kind of like a whole holistic view of the uses of libc?
I don't think we have, just because we haven't been at a point where we're complete enough to really get a good view from there.
Yeah, so we have to use the overlay libc, and we do internally use overlay libc in Google. That performance testing and all analysis is done by the 4th person on our list, Guillaume. Unfortunately, he's not local, so that question would be more suitable for him. If you want to follow up, we can start a discourse topic discussion and include him in the
Cool, thanks.
topic.
Muscle has a test suite for C libraries. Have you guys tried testing your library against Muscle's test suite?
Muscle's, I've taken a look at Muscle's test suite, and I believe we've done some testing with it, but it is not particularly complete, at least last time I checked. So it has regression tests and it has some other tests, but it doesn't cover every function. So I believe our tests pass. I know, I don't know how often we test our libc against other tests, but we have done tests where we test other libcs against our tests, and those pass. So yeah, I don't think we're using Muscles right now.
Yeah, so as far as I understand, Muscle's test suite was not built from zero. Like, they built it as they found bugs. And it's not part of the official Muscle source tree. It's maintained separately by not the main maintainer, right? Somebody else. That said, like Michael was mentioning, I don't know if it's Apple's libc, but some libc, which Apple is interested in, is actually using our test suite to test their libc. But for your question, though, we have not tried our libc against Muscle's test. Mainly because we are building unit tests from the scratch, and they probably are having tests which are testing the whole libc behavior. So we didn't get to that.
Does this string and memcopy functions support Fortify source?
No, we don't have support for Fortify source in any of our libc functions or headers. This was brought up recently. We have not yet come to a conclusion as to what to do with Fortify source. Is that right?
All right, well, thanks everyone for attending and listening, and thanks for the presentation.